Next part, we're going to look at using the equations that we just came up with here to help us find the sum of a geometric series. So example 4 says the sum of n number of terms is going to equal 30 plus 36 plus 43.2 plus dot 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 all the way till we get to whatever number of terms we're using. It says find the sum of the first 37 terms. All right, so let's add a little flavor to this one here. So for this situation, if we were talking about this being finding the sum of a series, we can write it in summation notation. So what we're going to say here is we've got our sigma, and we'll say that n is equal to 1, right? We're trying to find the sum from the first term to the 37th term. So we'll put 37 up above here. And then what is the argument? Well, the argument here should be this. And we can check it by taking 1, because this is the first term, and plugging it in here, making sure that we get 30 out. So we'd say 30 times 1.2 to the power of 1 minus 1, which is 0. 1.2 to the power of 0 is 1, times 30 is 30. So I know that this rule matches the series that we've got. So we've got 30 times 1.2 raised to the power of n minus 1. Okay, so we're trying to find the sum of that series. Okay, you got to be able to do that, and that's why we're practicing it there. So let's go ahead here and let's actually just use our formula. So we've got the sum of the first 37 terms should equal, okay, so we need to be able to plug in things here. Let's see what we need. So if we look back up at our formula up above, right, I need to do my first term times my multiplier raised to the power of n. Well, our first term is 30. Our multiplier is 1.2. We can see that over here, or you could, do 36 divided by 30 to get it there. So let's write those in. So we have 30 times 1.2, and we're raising that to the power of just n. Okay, so instead of n, right, our n value is going to be 37. So let's take it here and let's put in that 37. Then we're going to subtract our first term, which is 30, right? That's the part that's coming from here, minus our first term. Now on the bottom, we're going to need to take our multiplier, our r value, which is 1.2. Oops, forgot my decimal. 1.2, and we're going to have to subtract 1 from that. So all we've done is we've just taken everything here and plugged it in where it goes. This number here that you see should match this number right here. And then you'll see here what appears in here twice would be our first term appears in here twice, right there. And then our multiplier appears here and it appears there. And then this 1 is just, because we're subtracting 1 from this. So now, we can just take it and calculate it here. And I'm not going to calculate that by hand. I'm going to go ahead and grab out my calculator, and you should too. So here's what we got. We have here, and you can do this whichever which way you want. I'm going to do 30 times 1.2 to the 37th power. And then I'm going to subtract 30. And what I get there, 25,486.8675. I'm going to divide that by 1.2 minus 1, which would be, what, 0.2? And we get 127,434.3375. So we have 1, 2, 7, 4, 3, 4.3375. A lot of times these numbers can get long, so just make sure that paying attention to what you're doing. Doesn't mean because it's ugly, doesn't mean it's wrong. Just remember that. All right, let's move on to the next one. So if you want to pause the video here, this would be a great opportunity for you to try it yourself and see how it goes. Okay, so we'll go ahead and begin now. So I'm going to end up here. First of all, I wanted to take it and practice writing it out in summation notation. I've got, let's see, we're finding the sum from our first term to our 13th term, if you read it carefully. Okay, and then this rule should match up with this series here. If I plug in 1, 1 minus 1 is 0, 6 to the power of 0 is 1 times 5 gives us that first term. So we know that that works, and you do need to check that. So 5 times 6 to the power of n minus 1. All right, so the sum of the first 13 terms in this series is going to equal, if we use our formula, we have our first term 5 times our multiplier was 6 raised to the power of just n, so that's just 13, minus our first term, which is 5. And we're going to divide it by 1 less than the multiplier. The multiplier was 6, right? So we're going to do 6 minus 1. Okay, so now we'll go through and just simplify it down if you want there, or you can use the calculator to get it. So with this one, you actually could probably reduce it down, but we'll just use a calculator. I know you're more comfortable with that. So let's do 5 times 6 to the power of 13, and then we're going to subtract 5. That's a pretty big number, and then we're going to divide that big number by 5. And we get another pretty big number still. That looks like what? We'll figure out the place value here in a second. We have 130,606,94015. Okay, so we've got, what is that? 13,060,694,015 is our answer. Hopefully this is making sense to you, and we'll see you in the next problem.